Today we will look at an important structural element in wings, the rib. Ribs have an important function in wing design. They ensure that the wing maintains the aerodynamic shape or profile so that lift is generated as designed by the aerodynamicist. As an aerodynamic profile is defined in flight direction, ribs are often placed in flight direction also, even though sometimes it is easier from a manufacturing point of view to place them perpendicular to the spars. Secondly, they also transfer the aerodynamic and fuel load exerted on the skin into the rest of the wing structure. Next to that, they also provide stability against panel buckling of the skin panels. Another important function of ribs is to introduce local load into the structure. For instance, the landing gear, the engines, but also the flaps and the control surfaces such as the ailerons. Finally, ribs also have a sealing function in the case of an integral fuel tank. They prevent surge and splashing because you can separate fuel tanks into individual bays. Without ribs, the wing would have a much harder time functioning. The wing panels would simply crush and, if you do not put in enough ribs, the wing skin panels will buckle. That's why ribs are typically spaced 0.2 to 1 meter apart, ensuring sufficient distance. What type of rib to choose is then the logical next question that needs to be answered. As always, when designing things, there is not one final correct answer. The type of rib, closed, with lightning holes, or truss-shaped, to name but a few options, depends on the loads it has to carry. It also depends on the design philosophy used, which determines the magnitude of stresses allowed in rib structures. Seemingly more trivial aspects, such as the available equipment and experience, also needs due attention. Why, you might ask? If the company you work for doesn't have the equipment needed to make your design, it is highly likely that your design will not be chosen. The lead time in purchasing and learning to work with such a machine may not weigh up financially or time-wise with the savings your design offers in another area. That brings us to the fourth criterion, cost. At the end of the day, manufacturing aircraft or spacecraft is not a charitable activity. Cost must be minimized in order to stay competitive. Your design may offer the best solution on a micro scale, but may lead to an increase in cost on a larger scale. Again, this depends on whether the benefits of your design weigh up against the cost of implementation. This answer is different every time and is one of the reasons continuous optimization takes place in industry. This is also an explanation why different companies will have different solutions for the same problem. The design and the way they are manufactured are influenced by the load. If a rib has relatively low design loads, you will perhaps select a rib that is formed from sheet or plate material. You can create extra stiffness by adding stiffening profiles to that rib, as can be seen from the formed aluminium rib with a stiffened circular cutouts. Highly loaded ribs, in contrast, may be forged and machined to ensure they can withstand their design loads. As with fuselages, wing skin panels are also stiffened using stringers. As a result, rib-stringer intersections are unavoidable. One of three options are possible. First, interrupt neither, as shown here. Secondly, the stringer is interrupted. And finally, the rib can be interrupted. The selection on what is most appropriate depends on the loads locally and its manufacturability. Plenty to think about, therefore.